as I was figuring out and inventing my chord teacher and stuff, and then realizing that they didn't have any of the sharps and the flats, and they were the new notes, and it overwhelmed and complicated the system, and music really wasn't working the way that I've been taught. It really was sets of mathematics. These dials that we can dial up and find the notes on our guitars and find the notes on pianos. All these music chords are, let me drop in the light here, perfect angles and stuff. So figuring this out as a base 12 system, it's triangles, trapezoids, and stuff like that. And the piano teacher's pushing me really hard. I'm thinking about, should I invent this and stuff like that. One Sunday I get to church and he has this book. And he hands it to me. He says, Andy, he says, I want you to read this book. It's about this guy by the name of John Harrison. John Harrison was a clockmaker. It was about 300 years ago. He was the first person to figure out how to navigate ships around the ocean by using clocks. Before then, they would use the sun, the moon, and a tool called a sextant, which could measure from the horizon up to where the moon is, or to the sun, or to stars. And that's how they used to navigate ships around the ocean 400 years ago, but they kept on losing ships and stuff like that. And there's a problem for all of the
running
nations
aground.
So there was this longitude prize. It's a long story and stuff, but he hands me this book about this clockmaker and figuring out how to navigate ships around the ocean instead of using the sun and the moon, but by using clockwork. And so I'm reading through this, and as I got to the 4th and 5th page, there's a whole bunch of math that they're talking about, how I'm navigating my notes around by 120 degrees and then 90 degrees in these mathematical shapes. In the book Longitude, they're navigating ships around the ocean, around where the equator would be, in longitude and in latitude and stuff. But there was a lot of similarities in this book to the longitude problem and stuff. So I'm reading this book, and just about every week I'm finding more and more. I read the book cover to cover 11 times. And just kept on circling and stuff and showing my piano teacher, Phil. And he's pushing me to do this. Doesn't know there's no black notes. All these other Eastern people were shocked with all of the math I'm coming up with. And nobody at this point I talked to knew that there was new black notes. So like I say, I go to church with all these guys and praying, God, how's this work? Jesus, how's this work? How's this work? Holy Spirit, God, how's this work? How's this work? And I'm asking everybody, and asking musicians and people who play guitar, and I'm asking atheists, and asking people worse than atheists, drummers. They didn't know. They didn't have a clue. But I'm working on all this math, and I'm praying, God, how does music really, 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 really work? In December of 2000, I had this most vivid dream. I watched all of these notes go by forward, saw it all go reverse, so I go tick-tock, 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 as if I was in a clock or a watch. So I was inside this very, very, very vivid dream, watching all of the notes, all the chords, get out of this dream, start writing all of this mathematics. And the book Longitude was about a clockmaker. I dreamed it as a clockwork, but I work outside a lot, and I'm also every day I'm watching the moon and the moon phases and which way the moon is being illuminated by the sun and all of these different angles. And I'm reading this book over and over, and I'm reading it, and I had this extremely vivid dream. And after a while I started realizing not only could I describe it as the clockwork that it was in this extremely vivid dream, but if you could look at each one of the notes, pretending that this is the earth in the middle, and I'm looking out to where my note is, and where the other note that it's related to, it says G to G, exactly 90 degrees. But if you're in the center looking out to where the note would be, it would be exactly like looking at that angle. It would be like this moon phase, where the western side of the moon would be illuminated, the eastern side is dark. And the more I looked at all of these phases and stuff like that, and how it would be do, re, mi, fa, sol, la, ti, do. Every note is at a precise angle, but it would be like looking at moon phases figured out is, what do you call it? Must have talked. I'm going to put it up here so we get the better light. So this would be like do, re, mi, fa, sol, la, ti, do. It's very precise angles as it goes through the 6-to-1 ratio and the double helix that it is. But if you could be in the center and you look out to where the notes are, if you look here, it's each one of these notes would very, very precisely look like a moon phase, and it's how the notes are interacting with one another in these phases is how the harmonies interact mathematically together.
How the harmonies interact mathematically together.
So I'll show you. So here's QC. C, D, E, F, G, A, B, C. Would be 0 degrees, 45 degrees, 90 degrees, 135, 180, 225, 270, 315. And at 360, the next octave or key starts. So I'm inside this as a dream. And if you're in the center, if this is the earth, if the sun's shining down from the top, you're on the earth and you're looking up at to where the moon is compared to the sun. The sea here, it would be an eclipse there, a lunar eclipse, would look like this. And then in this dream, well, it's out like this. So now, from where the note D is, we're pointing into the region of D. From here, looking out, our moon phase would look like this. This goes 1. This comes out 7. We're in the middle here, looking out to where the moon / the note E would be. Moon phase looks like this. This goes 1. This goes 7. And now we're here at exactly 135 degrees. Moon phase looks like this. This goes 1. This goes 7. Now it's exactly 180 degrees. This is where the eclipse would be. This goes 1. This goes 7. Looking from here out, our moon phase look like this. This goes 1. This goes 7. 270 degrees. Looking out at our moon. Moon looks like that. This goes 1. This comes out 7. Where am I? Right here. 315 degrees. Moon phase looks like this. This goes 1. The moon comes in front of it. We have an eclipse there. As this stuff comes out, this being the long cycle system of 48 now, what I call the short cycle. It's a double helix, so it's do over sol, re over la, mi over ti, fa over do, sol over do, la over re, ti over mi, do 8 over fa. And then it comes back up, and then we have all of the step, half step, mysterious half step. The mysterious half step. There is mathematics to describe this. Did you ever take an electric motor apart? The electric motor's got 2 fields, and then there's a screw here, and there's a screw here that holds it to the case. It's kind of like that. We've got a field, what we call the even wedge, and then in the light blue, and then the purple here being the next field. If this was an electrical motor, there'd be a couple of screws holding that down. Kind of like in the what we call the short cycle.
Wow.
Then them half steps are these black lines.
How long did it take you to draw this?
From the time I had the dream until I had it out to about here was 6.5 years.
Amazing.
Then I had a second dream. Second dream. It must well, So here's our C, or do, re, mi, fa, sol, la, ti, do, angles and stuff. And so one night, about a year and a half after I had the first dream, I had a second extremely, very, very, very vivid dream. And the dream, stand back a minute. So in my dream, there's a whole trail of these 3-note chords kind of stretched out in a circle kind of behind me. And suddenly I see this chord coming down, and I'm watching it from underneath. And as it got to eye level, I looked through it, and it came down, fell onto the original drawing here, and it kind of like exploded like fireworks, and then it melted in like wax and kind of disappeared. And then very slowly look up, and I'm watching the next chord coming down, and I'm recognizing what the chord is. I can't remember off the top of my head. It was a major or a minor. Come down, got to eye level, looked through it, it lands, explodes, melts in. Watching another one come down, same thing, explodes. I'm watching B flat come down. And I know it's B flat because from underneath I'm seeing B flat, D, and F, so I recognize that chord shape in there. And it gets down, again, explodes on. I'm watching all these notes, E minor's coming down. And it gets about this far past me, and I realize I'm having another extremely vivid dream. And in my dream, I said to myself, Andy, wake yourself up. So I popped my eyes open, went out and got my original drawing, which is this, and I started measuring from where all of these angles were, and every single one of these 3 notes fell on perfectly into there mathematically. It fit in like gloves. I did not have a clue that they were going to fit in. I was just praying, God, I want to know more. I want to know more. Jesus, how does this work? How does this work? How does this work? And asking drummers for no help. And so, somewhere in this pile of stuff.
Fire away.
So here's the original dream. Second dream, I'm watching the 3-note chords falling on, and mathematically every single one of them fit in. This is coming down as major, major, minor, minor, major, major, minor, minor, major, major, minor, minor, major, major, minor, minor, major. And every one of them, 90 degrees, 120 degrees. Those notes from
You're
here.
following perfectly with
Yes, yeah,
That's awesome.
These two, the pointer arrow is the root notes, and then here's your 3rd and your 5th of every single one, from the root to where the arrow points to where the 3-note chords are around them, all fit in at either 90 degrees, 120, or 120 and 90, perfectly in there. I had not a clue that that was going on. My piano teacher, Phil, he gets cancer. He ends up, before he died, he says, Andy, by the time you're really, 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 really famous with all of this stuff, you're going to be dead for 200 years.
That's sad.
So, it's probably true. Well, I'm hoping, hoping and praying that it kind of works out that way. Set this over here. So, I told my piano teacher there was no black notes. He said, prove it to me. He died. And I find this. Originally, they had key of C, C, D, E, F, G, A, B, C. And then somebody starts it off, but from F to B, they flattened the B. We call it B flat. And then it goes on to say that the notes were probably, B flat was found first, and then probably this order, F sharp, E flat, C sharp, G sharp. And the other drawings have showed you, so there's the F sharp, C sharp, G sharp, going counterclockwise. They found B flat first, then they found E flat. Every time they found a flat, it's always found at the note Fa and ruled by this mathematics that we call spades.
mathematics state?
Yeah, because each one of these represents these sets of math. My daughter told me that 2 plus 1 is 3. This is 2 plus 1 is 3 is right here. This one's a 3 plus 4. It is a step and a half step, step, step. This one's a step and a half step, 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 known as the mathematics of hearts here. The spade is a step, 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 half step. This is going step, 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 half step. And then this one here is a step, step, half step, step, so on and so forth. So there's basically 4 sets of mathematics, and each set of mathematics has an opposite set, ruled by opposite sets of mathematics with the same patterns of steps and steps. I don't believe anybody else on the planet knows this. I've had this down to the Eastman School of Music 5 times. Shocked them. Absolutely shocked them. I asked them for a job. Still swinging the hammer for a living.
It's unbelievable.
So then, as this is a clockwork of math and related notes to one another, these half steps here break the music into what I'm calling even wedges and odd wedges. The even wedges here contain these 6 notes: C, D, E, F sharp, G sharp, A sharp, only and always fall into these even wedges between these half steps. And then these odd wedges, which are, being a clockwork, this is 1 o'clock, 3 o'clock, 5, 7, 9, and 11 o'clock. And these 4 notes of each wedge contains the 6 notes A, B, C sharp, E flat, F, and G. The half step is a mathematical phenomenon. So then, as these angles, as I was mentioning before, like this would be, I have to look at it. I drew these drawings a long time ago. Let me think for a second. So the chord C major ninth would be C, E, G, B, D. From the C to the D, that's perfect part of the circle of fifths. The angles are 0 degrees, 90 degrees, 180, 270, back to 0, or call it 360. And then D minor ninth would be 45 degrees, 135, 225, 270, back to 45. E minor ninth, and this is also true with other, would be 90 degrees, 120, 270, 0, or 360, back to 90. F major ninth would be 135, 225, 315, 45, 95. And again, each one of these chords, the mathematical structures are very precise as they go around. These 3 notes here is C, E, G, B, D, 0 degrees, and it's every other one. 90 degrees, 135, 180. I said that wrong. 0 degrees, 45, 180, 270, 260. These notes are spaced out in these perfect mathematical forms, and everyone would have perfect sets of math. We hear all this stuff.
Hearing math.
We hear math. And speaking about hearing math, you're watching somebody play, and all of a sudden they're making a mistake, and you can see their face as they're playing along, and they make a mistake, and it's like, oh. And you see they're panicking, but they're also you see they're trying to find that right note, and then they finally get the harmony. The reason we hear that note wrong, you put one of those angles out of at the wrong spot, and you hear it. It sounds, sounds like a sore thumb.
Amazing.
And then so I'm down at the Eastman School of Music, and I'm showing the chairman of the music theory department all of this math and all of the stuff and how it's a clock and how all the ticks are related to each other and the talks are related. Yeah, going tick tock, tick tock, tick tock, and again, there's 0 degrees, 90 degrees, 180, 270. Any three is a triad chord. Put 4 notes together is called a 7th chord. 5 ninth chords, and same over here, and they're all exact, precise angles. So I'm at the Eastman School of Music 5 times. One of the times I'm talking to the chairman of the music theory department, and the chairman, I'm doing most of the talking, and the chairman's sitting there, leaned back in his chair as I'm talking to him, and he says, "Well, Andrew, do you ever consider the circle of fifths?" And I wish I had a video of this conversation at this point. And I said, "Yeah, and how many circles of fifths are there?" And he looks at me like this. Is there only one? I said, "No, there's 7. And he screams out, "How can there be 7? And so I showed him the next one of these. And because they're sets of cards, these are the notes that we're using, and these are the steps in between, and the half steps coming down here. There are 7 circles of fifths." And he was just flabbergasted.
Wow.
And then our notes come in.
Wow.
They come in so we're going from club here, we're starting at C here, and I'm going 1, 2, 3, 4, 5, 6, 7. We have C here. These are both major chords here. Going backwards, 1, 2, 3, 4, 5, 6, 7. We're finding C is a minor here. 1, 2, 3, 4, 5, 6, 7. C is also a minor here. So we have C comes in C plus 7, C plus 7, C plus 7, C plus 7, C sharp plus 7, C sharp plus 7, C sharp plus 7, C sharp plus 7, D plus 7, D plus 7, D plus 7, D plus 7, 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 plus 7.
All right, pause.
Going around. It's going, the one spinning quickly is going plus 7, 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 7, 7, 7, 7. 7 is the most common number in the Bible. And all of the pleasing harmonies are 7s. Just going to be chair for a second. So as we're playing our octave, C major, D minor, E minor, F major, G major, A minor, B diminished. That diminished chord there sounds spooky, eerie. So we're going major, minor, minor, major, major, minor. That sounds spooky, eerie there. 4 plus 3 adds up to 7. 3 plus 4, 7. 3 plus 4, 7. 4 plus 3, 7. 4 plus 3, 7. 3 plus 4, 7. We get to the diminished chord here. 0 plus 3 plus 3, that adds up to 6. In the Bible, 6 is the number of man, but you also have Satan's number being 666. Make the hair on the back of your neck stand on end. God's number 7. Nice and wholesome. Happy.
I'm on a cloud.
Yep. Satan's number 6. It gets to be Halloween, and we have all of those Halloween movies that are advertised on TV, and all of the theme music is done in the diminished, spooky, eerie. Gives it that feel. So in the 15th century, when they discovered, after they found the last black note around the year 1450, and people started doing the math, I had no idea that people back in the 15th century did this math. Had I known, if somebody told me, I would say, oh, they did that back in the 15th century, I would have stopped because somebody else figured it out. Lots of people had figured this out. Nobody had showed, so I just kept on doing it. Stuff. So anyway, in the 15th century, when they discovered that, added up to 7, they called the chord the Diabolos chord, the devil chord, and you were not allowed to play this chord in churches. Get your ass in all kinds of trouble. You get away with it nowadays. Well, depending on the church, I suppose.
That just shows you the diminished times.
Yes, there we go.
Thank you.
So if our sheet music has a little 0, or it says dim, in this case B, B, D, so it's the right word to put your fingers on your guitar. And if we're trying to play that same chord, B diminished, we put our root to the B, B, D, F, slide this underneath the guitar strings, B, oops, where's B? So B, D, F. It's also here B, D, F, B, D, F. Find your notes, slide the chord teacher out from underneath the strings, and play your strings, and there's the chord.
Very nice.
Alright, so now all of these notes are angles, every single, so we got the spectrum here, these 48, but with the notes, what I call the short cycle. And again, ruled by a bunch of sets of mathematics, which are your root plus 4 half steps plus 3, this is the majors, a step, 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 and a half step. And the other major, which I call clubs, is your root plus 4 plus 3, and this one's a step, step, and then a half step and a step, but this was a step and a half step, it's flipped. And then the minor, it's a 3 plus 4, it's a step, half step, step, step. And then the other minor, known as the heart also, is a half step, 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 step. And those black lines, those are steps, and it's where the chords are tripping over this half step as they go through. The most common one, we got C, D, E, we have a half step, F, G, A, F, G, A. I didn't do it that way, I didn't sing that way, but you get the point. F, G, A, B, and then the half step to C, coming down through here in the spectrum. And then the chords are made up of different phases. Or they're made up of either these 3 or 4 notes or these 3 or 4 notes, starting from any one of these points through that whole spectrum, but always, always, always following these mathematical patterns. Wow. And so it's all about the dark side of the moon. So I prayed and I got a keyboard, or I got a piano. First book I went up, but Dark Side of the Moon from Pink Floyd. And so my son's helping me figure all this stuff out and stuff. And not helping me, but he was working with me at the time, so he was, watching all these moon phases while I work and explaining to him. He kind of had a little bit of a grasp on what I was trying to do and illustrate and stuff. But so anyway, it's all about the dark. The sun illuminates, but it's the dark side that gives me the notes from where it is all in this spectrum here. I'm rambling on right now. So anyway, Pink Floyd. And everything under the sun is in tune, but the sun is eclipsed by the moon. It's all about these eclipses here. What they call circles of fifths.
Circles of fifths.
Would go from where this is 0 degrees. The sunshine right here. Oops. To 90 degrees. Back to 0 degrees. To 90 degrees. To 0 degrees. Doing a perfect circle of fifths as eclipses. So this is the clockwork of it all. And the hands of the clocks are stretched as far as they can and then cover one another.
Amazing.
And if we could look at all of this stuff like it was moon phases, it would go from Let's get over here where the sun shines better. Yeah. Going from a full moon to a new moon, to what they call a full moon, to a new moon, to a full moon, to a new moon, plus 7, plus 7, plus 7, plus 7. Plus 7, 1, 2, 3, 4, 5, 6 is G. C to G is what they call the perfect fifth. And then starting at G and calling it 0. 1, 2, 3, 4, 5, 6, 7. G's perfect fifth is D. 1, 2, 3, 4, 5, 6, 7. D's perfect fifth, 7 notes, we call it a fifth. A, and then it's E, and then B, and then F sharp, C sharp, G sharp, as it's going from, oops, I missed it. I missed it again. From a solar eclipse to a lunar eclipse, where the full moon would be. There'd be a solar eclipse there at the new moon. Full moon, new moon, so on and so forth. And every one of these angles, every single one of those angles would be circles of fifth, but the easiest one to see and understand is from the full moon. Amazing. Just because that's where the eclipses are, and how many people watch the moon as much as I do. Lunatic friends, I know you're out there. So, music harmony has absolutely nothing to do with our natural moon. But our system is a clockwork. And if we look from the center to where the notes are, this being a step, step, half step, 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 half step, called do, re, mi, fa, sol, la, ti, do. Hands eclipse, new octave starts. This is the original octave, the original key. The key is C. I'm putting my arrow towards that. We're going to go C, D, E, F, G, A, B, C. The hand with the arrow is pointing towards C, D, E, F, G, A, B, C. Hands eclipse, the key of D is starting. 0 degrees, 45 degrees, 90 degrees, 135, 180, 225, 270, 315. To illustrate why I think this is important, there's a lot of reasons I think it's important. First of all, the way that music evolved out of Europe with just the white notes and the black notes, the sharps and the flats, overwhelmed and complicated the simple system they had, and no one's ever straightened it out. And I am volunteering to straighten this system out.
Straighten it out.
My piano teacher, Phil, he told me by the time you're really, really famous with all this stuff, you're going to be dead for 200 years. So I like to watch documentaries. So after he told me I was going to be dead for 200 years, I was watching a documentary about Michael Faraday. Do you know who Michael Faraday is?
Yes, the Faraday cage. And
yeah, all
that
the
stuff, yeah.
So it's I don't know, 170 years ago, maybe thereabouts.
Wow, I didn't realize.
I don't know what year it would have been, but it was way back. And they had a battery, and they put a copper wire on the battery loop, and they took a compass and they put the compass down on the energized wire, and the compass needle went to which way the current was going, or at least they thought so. It was really going the other way. They knew. And then they switched the leads on the battery. Now the current's going the opposite direction. The compass needle jumps and is pointing in the opposite direction. They had a they had a piece of steel. They took the copper wire and they wrapped it around the steel bar. And as soon as they hooked the two leads from the copper wire spun around they connected up all of a sudden like that. All of the paper clips on their table stuck to the very first electric magnet. He says to his colleagues one day, he says, I don't know where any of this electricity stuff's ever going to be used for anything useful in people's homes. I'm just really curious. I'm having a lot of fun with the experiments, but I don't know if electricity will ever be used for anything useful. With that in mind, I am writing this to the best of my ability. I'm going to die in 200 years from now, hopefully be one of the most famous musicians of all time. I'm a legend in my own mind. It would be nice to be a legend in my own time. But I've solved harmony. I've solved music. I've solved music harmony mathematically, and no one knew it needed to be solved in the first place.
Amazing.
I was just curious, figuring out the math for the chord teacher here, and nobody had seen the math that I'm doing to make up these chords. They're pushing me as I was figuring out the math for the dials here as triangles, trapezoids, praying, God, how does this really work? How does this really work? Had an extraordinary dream. 5-minute dream, 6.5 years to figure it out. And then I had a second dream, watched the 3-note chords fall on. And then last night, I had a dream that I was a car's muffler. So I'm strapped underneath the car, and the engine's roaring, and there's the catalytic converter, and I'm looking behind me, and there's the tailpipe, but I'm dreaming I'm the muffler. And this morning when I woke up, I was exhausted. All right, so that part is... Call me a lunatic, if you will.
That's great.
Also, another thing I couldn't figure out is our perfect fifth from C to G. That's a perfect fifth, and all of these chords, except for the double chord and the augmented, have what they call a perfect fifth within them. So from C to G, that's 210 degrees from C around to G. And I'm thinking that perfect fifth, it didn't really seem right, but then come to find out that as we're going from where a root note is to its perfect fifth, it's from here, it's actually 180 degrees precisely. But because the top shifted around 30 degrees, it's actually 180 degrees here in the clockwork, but here it's 120 degrees. There's a gap. Let's see.
Interesting.
So, people have been saying, well, Andy, you're a little bit crazy. Some people tell me, Andy, you're a lot crazy. And so to illustrate this, I put Mozart's biggest hit, did the math. Mozart did not write the words. At the time I thought he did, but he didn't write the words. But the music from a poem that was written 150 years before Mozart was born is here. Just keep your eye focused here, here, and here, but mostly right here. This is Mozart's biggest hit. Twinkle, twinkle, little star, how I wonder what you are. Up above the world so high, like a diamond in the sky. Twinkle, twinkle, little star, how I wonder what you are. Every single note is a precise and exact angle. 0 degrees, 0 degrees, 180, 180, 225. This is too hard to say, but you get the idea. So not only is it angled, but it's also looking like a pie chart. Be a little bit of this, a lot more of that, because these notes are related in both directions. So you can look at it as moon phases. It also would, like all these moon phases are exact sets of math as we're hearing all this stuff. Angles, phase. Old school, they would just do it like this. The notes that they're singing and the chords are here. Chord C, chord F, C, F. There's a G in there somewhere. As we're going. Twinkle, twinkle, little star, how I wonder what you are. Up above the world so high, is also A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Is also Ba, Ba, Black Sheep, have you any more? Yes, sir, yes, sir, thanks. And we have chords. We go 1, 2, 3, 4, 5, 6, 7. And the chords being our first, fourth, and fifth chords. It's that what they call a 1, 4, 5 song. Millions and millions of songs are 1, 4, 5 songs. Now I did that playing it in majors. If we do it in minors, so it's C major, and then we're doing F, F, A, C, going back to C, and then we're going up to G, G, B, and D. But if we do this song in minors, we're flattening the middle note to make that C minor. It's F major, F minor, G major, G minor. If I play the same song, doing the majors, twinkle, twinkle, little star, how I wonder what you are. If we do it in minors, it has a whole different feel. Twinkle, twinkle, little star. And move this over here. Can't reach up there. Twinkle, twinkle, little star, how I wonder what you. There's a whole different, sadder feel to it than the major.
Absolutely.
So I fingerprinted. Oh, you know, it's so easy to get off on sidetracking and stuff like that. Let's say before, as this came to me in a dream, and it's going +7, +7, +7, +7, +7, +7, +7, and it went C, 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 and then C sharp, C sharp, C sharp, C sharp, D, 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 D as it's going +7, +7, +7, +7. So I took each one of the notes apart, and because they come in 4 different sets of mathematics, they being a minor, minor, major, and a major, and then where the related half or the steps are. So it's like a handprint here, but then the next note, what they would call the whole tone scale, 6 of them. It's kind of like 2 different hands. Like one hand is flipped. But then these notes here, for instance, is the C's, D's, E's, C sharp, A sharp, F sharps here, always fall in here. Each one of those, what I call it, the fingerprints into the handprint, and then these fingerprints here There's 6 of them here, falling here, in these different wedges. Very, very, very extremely ordered.
Action.
Starting here, this is halfway through the key of F, but it's also the beginning of the key of C. And it would be C. This goes 1. This comes out 7. D. This goes 1. This comes 7. It's 180 degrees. This goes 1. This comes 7. This goes 1. This goes 7. This goes 1. This goes 7. I've renamed, added additional note names to. So we have the Willoughby scale, which the note B is O and C is note P. C sharp, for instance, is Q, R, S, T, U, V, W, X, Y, Z. So as this is coming around, this is going to note C, which is known as P. P. Now it's doing Q. Q, which is C sharp. Q, C sharp. Q, C sharp. D, which is note R. 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 And that's going C sharp. Where was I? Oh, there it is. C sharp, C sharp, D sharp, then E, 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 F, 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 plus 7, 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 plus 7. Following, again, another pattern within all of the other patterns.
Rabbit hole of patterns.
23 of them. In 25 years, I've come up with 23 different things, mostly in the music and the harmony, but I've also done prime numbers in 2 different ways, done Fibonacci sequence, and just patterns and everything. Oh, let's talk about the Fibonacci sequence for a second. Oh, no. I skipped math class. HHILA. If we use just our natural notes, in other words, the white notes on our piano, Fibonacci numbers are 1, 2, and 3, 5, and 8. Skipping over the 2 for now. But we got 1, 3, 5, 8. This is the chord C major, and when you put another C on top of it, it's called C major reinforced. So that's just using our natural notes. In the Fibonacci sequence, 1, 2, 3, 4, 5, 6, 7, 8. 1, 3, 5, 8. Now, if we use all of the notes, the white and the black notes, in what they call the chromatic scale, 1, 2 is Fibonacci, 3 is Fibonacci, 4 is not, 5 is Fibonacci number, 6 is not, 7 is not, 8 is a Fibonacci number, 9 is not, 10 is not, 11 is not, 12 is not, 13. So in that, using all of the black and white notes, again we got C, E, G, and C again being at 1, 5, 8, 13. It works either way, in just the natural notes or in the chromatic scale. Fibonacci's there. And again, we're hearing math, we hear that Fibonacci sequence. And then there's this guy Pythagoras. How much space you got?
Lots.